Hi everyone, I'm Naisha Kishore and I am pursuing my BTech in Mechanical Engineering from NITK. I'm currently in my third year. So I was preparing for my end semester exams where I thought I should revise my mid-semester questions as well, since I haven't done quite well in my mid-semester, especially this subject. It's called Turbomachinery. It's an elective, and yeah, so I haven't really done well. And I was hoping you guys could tell me where did I go wrong. So right, let's get started. Yeah, this is my midsem paper, about 4 questions. So the second question is what I was solving. A radial outward flow turbo machine has no inlet swirl. The blade speed at the exit is twice that of the inlet. Radial velocity is constant throughout. Taking the inlet blade angle as 45 degree, find the degree of reaction. Draw the inlet and exit velocity triangle. Is it a turbine or pump? Okay, so what information is given, I would just like to brief you about it. So radial outward flow, basically there is no c theta, like there is no tangential component of the velocity, of the absolute velocity. As though let's say swirl also indicates the same thing, that c theta 1 is equal to 0. And outward flow turbo machine also indicates that U1 is not equal to U2, which would further be stated in the problem. But yeah, so U1 is not equal to U2, and there is C theta 1 is 0. So the blade speed at the exit, which is U2, is twice that of the inlet. So U2 is equal to twice of U1, and radial velocity is constant throughout. So CR1 is equal to CR2. Taking inlet blade angle, which is beta 1 as 45 degree, find degree of reaction. Okay, so this is what I have done. I mean, this is what there. Yeah, and let me just download this. Yeah, I've downloaded this. I could rotate this for you guys. Yeah. So I have, yeah, as I had told previously, c theta 1 is 0, radial velocity is constant, so CR1 is equal to CR2, and beta 1 is given as 45, U2 is equal to U1. And this is ideally supposed to be the answer in the net, but let's see if I am not able to get it, so let's see how does it go about, okay? Yeah, so the next thing is this velocity triangle. I think I should have downloaded all this beforehand, but forgive me. And yeah, so this is the inlet velocity triangle. This is the outlet velocity triangle. Inlet velocity triangle, as you can see, there is no c theta component here, which is why this alpha 1 becomes 90 degree, and this is 45 degree. And okay, so C1, U1, W1, and here, since nothing is given about the angles, we'll be considering all this, but all we know that is CR1 is equal to CR2, but in inlet velocity triangle, CR1 is also equal to C1. So CR2, which is equal to CR1, will again be is equal to C1. So this is the formula of the reaction, degree of reaction, right? So now this is what we're going to solve. Next, yeah, so this is better. As you can see, this is, again I've written the same equation formula, but I have cancelled all the halves. And from the inlet velocity triangle, you can observe that tan beta 2 is equal to C1 by U1. So as you can see from here, tan beta 1 is equal to C1 by U1. C1 by U1, 90 degree. And so that it's beta 1, my bad. Beta 1, not beta 2. It's 45, which is equal to C1 by U1 is equal to 1. So C1 is equal to U1. But as you can see, CR1 is equal to CR2 is equal to C1. But C2 is is the velocity which is made up of two different components of velocity, that is tangential component and radial component. So C2 is equal to root over CR2 square plus C theta 2 square. We know CR, what is CR2, and then we don't know what is C theta 2, so this is what I have found. Next again, for beta 1 cos 45 we have done here, and yeah, so cos 45 is what we have done, and yeah, we got 1 by root 2, which is equal to u1 by w1, and we got w1 is equal to root 2 by u1. Now what's left? I mean, all the inlet velocities are converted into u1, into the variable of u1. Okay, so all variables to u1. Now C2 is there. Now from tan beta 2, we are supposedly taking tan beta 2, because let's just say because beta 1 initially was given, so I was thinking that probably beta 2 would be there in the answer. Right, so and then what I have done is, from that we got C theta 2 as u1 by tan beta 2, which also can be written as u1 cot beta 2. So adding all that to C2 square, we get C2 square is equal to U1 square cosec square beta 2, which is again C2 is equal to U1 cosec beta 2. And you know U2 is equal to U1. So from the outlet velocity triangle, which is basically here, you can see W2 is equal to this length of the triangle plus perpendicular square. Perpendicular square plus base square is equal to W2 square. So that's what I've done here. Yeah, so I've done the same here, which is basically CR2 is equal to C1. And so we have gotten all this. Now, basically I have gotten all the variables into the some form of mu1, and so I've just substituted into the formula of degree of reaction, and I have gotten this. Okay, so I've gotten this much like this, but now the issue is, once I solve it, I get 4 minus cot beta 2 by 4. Okay, and but the answer, as I showed initially in on the net, is, you know, the I'm sorry, give me a minute. Yeah, 2 plus cot beta 2 plus 4. So I have gotten 4 minus, and here it is 2 plus. So I was wondering if you guys could help me find out, probably some mathematical mistake or somewhere I've just done something. And also, yeah, since C2 is greater than C1, it is a compressor because kinetic energy is inputted or is put into the fluid. Okay, so yeah, so that much is basically the question. It wasn't very hard, but mid-sem out of like 10 marks, I got 7 marks because I just couldn't find the last part, which is like I got cot beta 2, but I couldn't get 4, and the denominator also was messed up. So yeah, I hope you can help me out. Thank you.